Hello and welcome back, my ducklings. Today we're going to be looking at the Crayon Rock Cycle activity. So this is to help kids who might have been absent and weren't able to make it up themselves. They can watch this video, follow along on the procedures and their student guide in order to fill it out and still get, the idea of what we're trying to show. But also, if anyone did or they were able to do the lab, but maybe they just needed a refresher, needed to kind of see what was done again, they can go back and watch this video as well. So what we're going to do is we're going to demonstrate the rock cycle and how rocks can turn from one type of rock into another. I'm going to start off with this blue rock. I know it's a crayon, but bear with me. So if you notice, nice smooth coloration, we're going to say that this is an igneous rock. Now what we're going to do for part one, because there's 3 parts of this activity, is we are going to take this igneous rock and turn it into a sedimentary rock. Now sedimentary rocks are made when existing rocks go through weathering and erosion, and they break off into some very small pieces and particles called sediments. So first thing we have to do is make our sediments. Well, I've already got some made, but first thing we're doing is shaving off pieces of the crayon. So this is a rock. When we shave off pieces, that is us making our sediments. I already have some sediments from other crayon rocks already made, so now we just gotta add on to it with this rock. We're just taking the plastic knife, cutting off pieces of it. Just a little bit more. Okay. So I already had some made. There was purple, and then white, and then orange, and now blue. Now we have our sediments. The next thing that occurs in order to make sedimentary rocks is they have to be deposited in layers, which we did, and then they have to go through long periods of time where they are being compacted and cemented together. So as layers cover them up, over time, those heavy layers push down on it. And over many, many years of all that pressure pushing down, it'll cement them together. So we're going to demonstrate that by folding over the foil. And then in the instructions, it says to step on it. I'm just going to take this heavy beaker of water and kind of push down on it. So, pushing down, pushing down, pushing down, making sure it's all cemented together. Yeah, all right. When we open it back up, we now have everything squished together. Yeah, let me try squishing it a little bit more. I don't think I put enough weight behind it. All right, I guess I will have to step on it. Okay, so give me a moment. And step with all my weight. This should work better now, because I do weigh more than a beaker of water. So we open it back up. We have all these little pieces, but they've still been cemented together. Now, if we were to take some of it, it's kind of breaking off before I can pick it up. There we go. Here's a chunk. But as I kind of show you, there's a broken piece. You can see the layers of coloring within the piece. All the colors are there, but they're kind of in layers. And that's how you make a sedimentary rock out of crayons. All right. The next step, the next part of the activity is to take our sedimentary rock and create a metamorphic rock out of it. Now, how metamorphic rocks are formed is enough heat is added to soften the rocks, but not fully melt it. Think of it kind of like Play-Doh. And then with the intense pressure of everything that's above it squishing down, it kind of squeezes all those squishy rocks together until you get a new type of rock, and that's a metamorphic rock. So what we're going to do is we're going to take our sedimentary pieces. We're going to fold or put it all together again. Just kind of put them in the same area of the foil. We're going to fold it again, and now we're going to close up the foil. We're going to seal it. Now we said for metamorphic rocks you need enough heat to soften the rocks and pressure to squeeze the softened rocks together. And that's where our hot plate comes in. The hot plate is going to supply the heat, and then the beaker of water is going to supply the pressure. We're only going to leave it on the hot plate for about 5 to 10 seconds. So dropping it on, putting that on. Now we just wait a few seconds. Obviously at this point, you want to be very careful, safety first. You don't want to touch hot glass or the hot plate, and you definitely don't want to put any plastic on the hot plate because it will melt, and that would be bad. All right, sounds about good. The water wasn't on there long enough for it to get hot. All righty. So now let's take a look. Thankfully, the nice thing about foil is that the ends of it cool kind of quickly. Once it's cool enough that you can touch it, you can go ahead and open up the foil. And there we have our metamorphic rock. It's not all grainy and layered like the sedimentary rock is. We can see streaks and we can see different colors, but it's all kind of solid together. Again, not grainy, not layered, but we do see streaks in it. And that's what is kind of characteristic of many metamorphic rocks. Now the next step we're going to do is take our metamorphic rock and we are going to turn it into an igneous rock. Now how you make an igneous rock is by intense heat that actually melts rock. Yes, rocks can melt, but it takes very, very hot temperatures. Nothing you can do in your house. So the first thing that happens is very intense heat. I know I got some purple on my nose. Very intense heat to the point where the rocks melt. Now, melted rock is called magma. Magma and lava are pretty much the same thing, but magma is what we call it when it's still inside the earth. Lava is what we call it when it's been erupted and is now on the surface of the earth. So what I'm going to do now is I'm going to break apart, just for sake of time, break apart the pieces of my metamorphic rock. Because we're going to speed up the melting process by putting it into smaller pieces. So again, you can kind of see how with our metamorphic rock, not so much layers, but streaks of color. Like I said, I'm just trying to get it so it's all kind of not connected, but in one area of the foil. Smaller pieces and having it all in one area is going to help us speed up the melting process. Because we don't have the time that, geology has. Geological time, 1,000 years is a blink of the eye. We don't have that kind of time. Although igneous rocks are they could be the fastest ones to form. Because, let's say if you're in the lava fields of Hawaii, you toss a rock in, it's going to melt pretty quickly. And if you have a way to safely get some of the lava separated from the main lava field, then it can cool relatively quickly. But metamorphic and sedimentary, because they require pressure, anything that takes pressure is going to take a long time. I know I put a couple rips in my foil, so I'm trying to make sure that those parts aren't open and exposed. So I've used the foil to create kind of like a little bowl. The point of the bowl is just to keep the crayons from spilling out onto the hot plate. So we can kind of keep everything all localized. Less mess, less fuss. Okay, I have all my little metamorphic pieces right there. What I'm going to do is I'm going to put them on the hot plate until they melt. Now the thing about magma, it's not static. Magma moves, it flows. Even in the mantle of our planet, there are convection currents that kind of move within the magma and help mix it up. So we are going to use some metal tongs to help us demonstrate the convection currents within the magma that help to mix it up. Okay, so I'm going to go over back to the hot plate. Get this a little closer. Put that on there. All right. Sorry about the reach. So what I'm showing now is the heat causing the metamorphic rock to melt. Now I don't have enough hands to keep my computer up while I show this next part, but keeping the foil pretty in one area, I'm going to mix up the crayons while they're melting. Again, that's symbolizing the motion of the magma. It doesn't stay still, it moves around. And as it moves, it's going to mix up whatever gets melted into it. All right. So now I'm going to carefully remove this from the heat. Whoopsies. There we go. We're going to let it cool for a moment. Okay, so letting it cool. Turn off my hot plate while I'm waiting. Okay, it's almost done cooling. You can at least take a look and see it's a lot more uniform in color than, than the metamorphic rock or the sedimentary rock. A lot more uniform in color, in fact. And not just that, yep, it's all dried now. Flatten this out a bit and see the color a little bit more. Remember the crayon we started out with? We said that this crayon represented an igneous rock, how it was smooth in color and texture and all that. Well, take a look at that. A lot smoother in color. We don't see the different streaks that we did with the metamorphic rock. We don't see the grainy layers that we did with the sedimentary rock. We see a more or less uniform color and texture. And that is how you make a crayon igneous rock. All right, so that's essentially what the lab is. Hopefully this helped, especially, like I said, if you're absent or if you just need to come back to see it. But I hope that this was useful. Remember, kids, you can always send me an email or ask me questions in class. You know I'm always here for you. But if you have any question on it, definitely let me know. Otherwise, this should help you to finish up that lab report, the student guide. And I hope this also helped you to understand what's going on in the rock cycle. All right, everyone, you take care, stay curious, as the Amoeba sisters say, and just stay awesome. All right, be safe. Bye-bye.